In this video, I will show you how to use the lexicon modules and synchronize them with each other. So the first thing you can go is to the GitHub page, and then you're gonna have several examples here. I already put like 3 or 4 examples, one for distribution and 2 for the sequence. So what I mean by graphs that can be synchronized is if you go to this third gist here, you're gonna have 2 distributions, and then you can adjust the size according to your taste, and then press the local button. Now what you can do is you can go through the points individually. What happens is if you turn on the second tool again for the other distribution, they will be synchronized with each other. So you can look through the same part of 2 different data that matches in length, and then you can see how it changes within 2 distributions. Now, there is not much interesting going on in this sort of setup, but what you can do is you can sort these variations, and then you're gonna have a more interesting trend. For example, in this case, I sorted out the data points in this left histogram in an ascending manner. Okay, it might not always make sense scientifically, yeah. But for example, think about company sales versus some other parameter, and then you sort one based on the time scale, you sort the other one based on the volume of the goods that are sold, and stuff like that. So here in this case, one is sorted in ascending manner, the other is left default. With this way, you can reveal some interesting trends. The same thing goes for many of these lexicon modules. Not all of them are being able to be synchronized with each other, but most of them, yes. This is another one, a sequence visualization. I don't know if this is going to have much adoption opportunity other than bioinformatics, but you can, if you ever need a visualization where you need to show a string of sequences, you can try the 5th example here. In this case, I have 2 applets. They are using semantic rendering. So basically what's happening is every time you re-render the scene, the document tree is changed. But I can also mimic geometric zoom. So if I zoom out in this one, the other one will zoom out as well. The below one is gonna act like if it is a geometric zoom, the upper one is gonna keep the height of the elements constant. The interesting thing is when I drag these tools, they will move together. If I go like that, they will also move together as well. So you can synchronize as many of these sequences as you want. For other lexicon modules, you can do similar things. Here there's a GIF, 2 plots, and then they're compared and synchronized with each other. To do that, I don't have live examples of this now. I have, but it's not in the as a gist. You can go to mutaframe.com. Mutaframe.com is the project that we have featured in one of the white papers I listed in the GitHub. So what I want you to do is, instead of getting redirected into the mutaframe.com, I want you to type mutaframe.com/index.html. Okay, mutaframe.com/index.html. And now I want you to make a hash character, and then I want you to type this thing. So you're gonna pass in some parameters via the hash, and it's gonna determine which tools we need. So hash, and then t equals gen underscore deo underscore dyn underscore sel exclamation mark. Okay, and then hit enter. Nothing. It's gonna seem like nothing has happened, but it's fine. Now you go to the input box and type Q5JU85. All right, a sequence is supposed to pop out here. Select that one, hit the play button, and then you're gonna have a protein sequence. It's not really important what it is. So we're going to go to R863. Okay, this over here, R863, and then you click on it, and then you click W. So we're gonna make a mutation here, and now we submit, and then you're gonna have some data coming from the server. Now if you scroll all the way to the bottom, you're gonna see some modules here, some plots. First, for brevity, let's select all of them. Okay, and then we're gonna go up again. Now we're going to expand this part, and now we're going to remove them. Okay, so we did remove selected. So now we have nothing there. So now let's choose like two things to compare, sheet and then sidechain. I don't know. And then once you select them, click the plus button, scroll down again, and you're gonna see two here, three modules. Okay, the upper one, the lower one, and then a comparison of these two. So first, bring the lower axis down, and then let's change these a bit. So these are basically plots. I did not run the numbers. There's a lot of things to iron out, but this is the general view of your data. And then this is a more larger view. You can zoom in, you can zoom out. You can change these bars, compress them, and then expand them. You can change the color. You can bin them, and also you can morph individual elements as well. So in this case, based on the data, they can become a circle or a triangle. So each of them is a different amino acid. It doesn't matter what they are. So now let's go back to the basic view. Yep. Make the bin size minimum, and then let's change the color of this one so it's a bit more visible for you. Okay, so what's gonna happen is this graph underneath is comparing these two. Here's the common axis. You have the sheet below, and then the helix. The sheet above, and then the helix below. The sheet here, the helix, and this is the common axis. When you move this box, you see that the rest of the plots are moving as well. And you move over these smaller graphs, you also move over there in the main plots. These are cross sections of this pseudo 3D layout. So this is not real-time 3D rendering. It's just a 45-degree view, and then you have three possible cross sections. So each of these cross sections are there. When you mouse over these, you also mouse over in the box and the plots. So now what we can do is we can synchronize these three of them with each other. The box controls the two, but the other two does not control the box. So now select them, and then we go up, and then click on sync selected. And when we go bottom, let's move the box. It's normal. Now let's try to zoom out. You see that the box will respond to that. When you zoom in, the box will get thinner. When you zoom out, the box will get thicker. So now let's add another plot. Let's add coil, for instance. Now we have another plot down there. So what I'm going to do, change this, the shape of these a little bit. Okay, so let's synchronize these two. Now let's see what's going to happen. Now the box controls the lower one. The lower one controls the box. But since the box is synchronized with the other two, I'm going to zoom out a little bit to show you. The rest also is controlled by this module. So now I move the one below, everything moves. If I move the box, everything moves as well. If I zoom out in this one, the bottom one will respond as well. We can do something more interesting. Now let's make another comparison. For example, this one and this one. So now we have three more comparisons. Now the box controls all three of these. And what we can do here is now we synchronize this box with this box. All right. Now, but this one only controls this box. But since it's controlling that, now everything will move together with each other. Now, if I zoom out in this one, the lower box and the rest of these plots will expand, will respond. If I make them, if I zoom in, they will also zoom in. If I mouse over in one of these points, you will also see it in the rest of the plots, not only these four in the bottom, but everything. so they will all move together. This is just to illustrate that how lengthy and how creative you can get with it. Obviously, there are a lot of issues, like I need to round these numbers and maybe work a bit more on the UX, but the premise of components that can be synchronized with each other, I think, is a strong one, and there's a lot of material to build on it. Not every drag gesture here is throttled, so you might have performance problems. You might not have as high FPS as you would expect, but I will throttle these drag functions in the upcoming versions. But still, you will get a steady at least 30-40 frames per second in Chrome, even when you have like 10-15 applets all running at the same time. So this is just a short demonstration. Don't forget, you go to mutaframe.com, index HTML, and then you make a mutation, which I shown in the beginning of the video, and then you will have access to this whole stuff. If you want to experiment with it, you can select all of them, and then you go up, you remove the selected ones, and then you can add new comparisons via this section over here. Okay, that's all for now, and have a good day, and I'll keep you updated. Don't forget to check on the main GitHub page and also the YouTube channel in case I upload new content.